Good morning and welcome to the Systems Engineering Cyber World discussion this morning. On behalf of NetApp, the sponsor for the Delivering Capabilities Theater, it's my privilege to introduce this morning's distinguished speaker. I'm Don Zimmerman, the account manager for NetApp to Fourth Estate agencies. This session is approved for continuing education, so if you would like to receive that credit, please look for someone at the end of the session standing at the back who will have a scanner. Our speaker this morning is Mr. Ernest or Ernie Hibbs, who is currently the Division Chief for the Cyber Development Directorate Engineering Division at DISA, which also involves his role as the cyber engineer in the Cyber Development Directorate. His role provides an overall directorate-level coordination for cybersecurity capabilities by producing the Cyber Development Roadmap, integrated WBS, engineering processes, baseline reviews, and architectural capability modeling. Mr. Hibbs has been in DISA for over 12 years and was previously the Chief Engineer for the Cyber NetOps Division, the Chief Engineer for MNIS, the Multinational Information Sharing Division in the IE Infrastructure Executive Division, and the Technical Lead and Architect for the GCCSJ, Global Command and Control System, Common Operating Picture. Prior to his employment at DISA, he was a Systems Engineer, Requirements Manager, CMM Process Involvement Lead, or Improvement Lead, in the DoD Clinical Information Program Office, the AKO Deputy Program Manager, and he had a previous career maintaining, managing, and developing submarine combat systems. He holds a BS in Computer Science and a Master's in Software Engineering from the University of Maryland, a CISSP, along with Acquisition Level 3 certification in the Information Technology, Engineering, and Program Management career fields. Please join me in welcoming Mr. Hibbs.
Thanks, sir. Thank you. Well, thanks for showing up this morning. It's not often do I get introduced by a retired three-star, so thank you very much. So today we're going to talk about system engineering in a cyber world. So if we think about system engineering, the first thing that happens is you start to fall asleep, right? You're thinking about how much discipline is this going to take? What is he going to do? He's going to preach processes to me. But in the cyber world, we're a victim of our own success. Most part, really, the U.S. is more of a victim of its own success. As I was dealing with multinational information sharing services and other coalition, the other countries will tell us that their infrastructure is not up to the speed that we have. Their capabilities aren't up to our speed. They try to get our capabilities hosted to them. So believe it or not, you may complain a lot about not having the right G level and not having the right service or a little bit of weight, but in other countries, we're pretty cutting edge. So what does that make us? That makes us a target for people who don't want to play friendly, don't want to help the warfighter, and just want to ruin services because that's their tactic. So system engineering in a cyber world, if we think about what you could do as a system engineer, the biggest thing you can do is keep your program manager and your PEO with a focused, concentrated, documented, quantified decision, right? You want to save your PM, you want to save your PEO, and you have to make sure that there's enough information for that PM, PEO to justify this is why I'm not going to do it, this is why I'm going to do it. Next slide. Oh, I'm sorry. I'll get used to this. It's technology, right? Oops. Back. Okay. You saw some of the second slide, so you're going to cheat on me. Reasons that SE is not done in cyber. What we're going to talk about is we're going to get some complaints about probably is how many system engineers do I have out there? A good amount, about a third, good. And then we're going to talk about if we try to prove or provide a rationale for system engineering in cyber, you have to use some kind of framework. So we use the .mil-pif. Many of you are familiar with that, but you haven't applied it to an IT or specifically to a cyber realm. And next, there is another layer of analysis or another layer of trade-off that has to be done. If you're going to do cyber, it should be based on a threat framework. How many have heard about the threat framework from NSA? Okay, we got 2, 3, and that's good, good, good. So there's also the MITRE ATT&CK framework, same type of framework. I want to start preaching on the slide already, and I'm not there. So the next will be a very short slide on the benefits to the program. It's going to be pretty much obvious by the time we get through here what the benefits that you can provide if you try these type of techniques for your program manager. So let's get it started with, I'm going to take 5 reasons that you think system engineering is not done in the cyber world. 5 hindrances, 5 challenges. Can I get 5? Give me one. There you go. Wait. Money, that's a good one. So that's overall. So if we have cost, schedule, performance, right now we're already constrained by cost. So then we have schedule and performance, which you think you can get both of those at the same time? No, you can only pick one of those. Yes. Complexity. Wow. See, you saw the slide. Did you cheat on me? No. Okay. Then we'll change your name to clairvoyant, but that's very good. So complexity, yes, it's a lot. We're going to get into just for like a couple minutes of what is real complexity for cyber and why most people have no idea why it's not just deploying an IT product. That was 2. We got 3. Hey, there we go. What? Agility. Okay. Yeah. That agility for moving once something gets into a baseline, especially inside DoD. That's a good. We have to get the acquisition process, and we don't want to go. We'll go into that a little bit, but it's obviously not going to be pleasant. Go ahead. Lack of experience. Very good. So lack of experience maybe on the latest tactic, and also lack of experience on general systems engineering, because you want cyber/IT people to be taking an engineering approach, and they may not be up to that level of performance as far as modeling a system, or maybe the threat framework we're going to go into. That's 2, 3, 4. One more. Anybody? One more. Velocity to change. So related to the other one, so what you can't do, and then what the demand of the velocity of change is. So how quickly can we actually change our requirements? I think we probably need to propose to you that requirements as informal requirements may be a little, that approach is almost obsolete because things move so fast. So we're dealing with capabilities, and we're dealing with, think about threats, and then you're already dealing with the current architecture. All good responses. So, okay, so somebody said it, you said it, complexity of the problem. Let's go into this, why is this so stinking painful? Well, once again, we started with ballistic missile systems, mainframes, computational algorithms, and then we went to business systems, and then we went to specifically IT, information systems, and then we found out, oh my gosh, we have enterprise services, and they're built in this language, or Java, or this other language, and they run on an operating system that's on another language, and then they run on a hardware set that's in a different language, and it's a different binary object. And, we thought it was just easy De Morgan's laws, right? It's very simple, but it winds up being a predicate calculus problem. Has anybody had to deal with that in school, predicate calculus? Yeah, there you go, there's one person, there's 2. That's it, I see the hands going down. That's it, and the rest of you are falling asleep. So let me make it very simple, if I can, make complexity simple. Defeats my purpose, but that's what I do. So all of the programming languages we have translate over to one or more of Chomsky's hierarchy of languages. It's a linguistics problem, right? So when you deal with your mainframe or your server, and then you deal with the language that's going to get deployed on an app, and then you have your middleware, and then you have the new chips, and then the new OS, you basically have a United Nations of languages, and there's holes in the languages. So what did we do? I can go back 20 plus years now. I'll drop the buzzwords of ADA, right? Some of you have been around. Some of you know our lessons learned with that. So we took a language and we took a regular type language and we tried to type constrain it enough so that it would be safe. So that it would be safe with our weapon systems, it would be safe with database management, and we kind of dropped that off, and now we're doing C++, we're doing Java, and there's holes in the languages, put it that way. So it's almost like, I'll give you an example of, you say, well, this isn't a language thing to me. I don't get the language thing, Ernie, and just hold on, I'll help you out. Every script that's written is a language or a grammar. It has rules. It's executing something. Every application has rules, and it's within some kind of boundary. If you remember, probably a year and a half, 2 years ago, we had a chat warning that you had to watch out for executables in your chat. The chat is a language, right? So it's XMPP, so you say, here's the rules to do it. So SMTP is a language. So you're executing things under a rule and a grammar. I know I'm killing this bullet, but I just want you to understand how painful this is. So we can't just throw regular engineering tactics at this. So this is an R&D type problem. And there's more effort put in overseas from our opponents or adversaries into language research and how they can take advantage of a language problem. So I've killed that. I really killed that bullet. Sorry. So excessive funds, that was another one that was talked about. So we talked about lack of funds and excessive funds. So excessive funds, really, when you think about, you only have so much time to get a project done, deployed, and what do? We admire the problem. So I'm going to give you the buzzword. And we talked about, you said the hindrances before. I got 5 of them. I got 5 of them. So my biggest hindrance, and it'll be the theme that you're going to kind of, we'll probably have to do a cheer session like every other slide or something, is the biggest hindrance that I have is egos. Right? That's not engineering grouping of objects. That's egos. That's people. Right? Everywhere we go, there's an ego. So our job as system engineers is to neutralize this. And then sometimes, as you know, if you're a vendor, you play the game, who's on that red team, who's on the source selection, what's the strategy on this? Well, all we're trying to do on the government side is get the best solution out there to give the best service. But there's all these games. And then there's power plays. We won't say who. I'll let you just dream up in your own mind all the people you know that are doing power plays within your own organization, and maybe because there's no pay raises recently, so they have to get promotion to get pay raises to take care of the extra car in the house. There's games involved. There's people. And then there's egos. I want this. I've got to have this. So anybody disagree with that one? Anybody have like a monastery or a convent full of people that don't care about their own needs? No. So it's going to be there. All right. So, but we spend a lot of time just talking about the problem, just like this bullet I have. So, and you can tell usually when someone's been talking about a problem too much because they say, oh, we're not going to solve it here. I said, well, okay. Well, things you're never supposed to say is, well, you're probably not going to solve it anyway, but you're not allowed to say that, right? So you're not going to solve it here, but we just wasted 20 people in a room for an hour, and let me see, how much does this cost me at $200 a head, and the government's paying for this, it's $4,000. You say, this was probably not a good use of government dollars. So key point in this, when you talk to engineers, and you never let an engineer just kind of voice their opinion, because we will say, okay, this, and there's no commitment, right? So we talk with diagrams, we talk with capabilities, we talk about input output, and you get some kind of specific thing going written on paper. Otherwise, it'll just go around and around. So the next thing that people don't like about engineering, or I came up with, is every time I try to initiate some kind of process, doesn't even have to be a big process, is they say, there's so much paperwork involved, then I need a staff on this, and I don't want to do this. And then, of course, they're actually right. You know, got to give them some credit. And then in every task you have, it's just like looking at the CFC. What's the management overhead for this? Okay, I'm going to have all this, and then what's the return on investment? It's not going to be that high. So these are the things. These are the ways people look at system engineers, And we've got to change it. You've got to make them believe that you're not like that. Or if you are like that, you're only like that to a certain degree, or you've got a specific reason that you need the overhead. Okay, so forcing engineers outside of their skills. I don't know how many times I hear somebody say, hey, that person's over there is pretty sharp. I'd like to make them my process engineer. Let them put some, but that's not what they do. They're a system admin. So you want someone with more of an analytical skill. So if you pick the wrong people or you try to push the skill on them, the ramp up speed is going to be what? Excessive. Then you're going to say the engineers aren't that good. You go back and forth. What's the killer here? The needs of the PM. But the needs of the PM also change, right? Based on where are we at in our life cycle. Oh my gosh, well, you finally got me that response, but I really needed it, 2 weeks ago, and now my decision is this. So your job as system engineers is to talk PMEs. I don't have to get, any kind of antennas or something up there to talk to the program managers. You need to take some acquisition courses, and you just don't let the program analyst take your contract and say, here, I'll see you in a month, and here it is. Chances are that contract's not going to be what you want, so you have to work with these people. Otherwise, you're not going to be able to work. Okay. Bottom bullet is almost pretty obvious now since we talked about complexity. But getting a team together that you can allocate and then the resources and all the personnel problems that the engineers have, along with the PMs have, along with the agendas that other people have, just getting something up and running and synchronized across the board in a life cycle, it's harder than sitting and building a design. If I ask engineers, so I'll do this because this won't put you on report or anything. If I ask engineers who would rather do diagramming, write code, compile software, do testing, or would you rather sit there and try to organize with a project plan approach all your engineering? How many people would rather do the project planning approach? Oh, well, there's one sick person. So, but actually that's not true. That may be one of our wisest people here. So you actually have to tie arms with the program planners and make sure that you have the resources for each of the steps of everything you want to do. The lecture has to go an hour, so this slide's succeeding very well. So those are our problems. Now, why do we need system engineering? Because we have organized crime. Cyber crime is organized crime. They live for it. They get paid for it. It's on the same realm as child exploitation, illegal trafficking, drug trafficking. This big money is associated with cyber crime. So we're just going to put more people on the ops floor and try more things and get a lot of smart people, and it can't scale. We've got to be able to dissect the pieces into something that's an engineering approach. Okay, and next one you may not have thought of is that some of your enterprise services and enterprise capabilities, I won't mention vendors because I'll get in trouble maybe, I don't know. So, but their inbred security capabilities are becoming so robust that to stand up a separate security capability doesn't make sense. Why we want to do it, and why aren't we just having the vendors say what it takes to protect their own product? So why are we trying to do this with a one-size-fits-small security solution? Probably not a good way forward. But we'll do that. I mean, we'll fill the gap for temporary purposes, but we have to change our engineering concept. If I have to shut down a security solution now and migrate from it, I may use something that's an enterprise service to do it for me and get away from just buying another security capability. So that's anybody vendors out there, that's the buzzword, is you don't want to come with another one-to-one replacement for me. So that's the foot stomper for today. Okay, high return on investment, systems to systems approach. We've already talked about how complex this is because you're talking about OSs and languages. And also applications, and then mobile devices, and then the WEAP formats, and the protocols, right? Little complex. All right, the extra dimensions of the decision. So we talked about the decision for the PM. We're going to go into a .MILPIF approach just as an example, and then I'll show you why it really didn't succeed. And I'll give you, let me see, can you guess why? Everywhere that we go, there's an ego. Okay, you got it. I was hoping somebody would be. Well, a couple more slides and we'll be all in tune here with the wherever we go, there's an ego, and that's going to be one of the things we have to stabilize, right? So the .mil-pif approach, standard approach for DoD, doctrine, organization, training material. You don't do this for every decision, but for the big decisions or to justify something for your program manager, you've got to find out what the pet peeves are. And I'll say pet peeves because it's not just, oh, this is good, this would be quicker, this is an engineering twist, I need more, this will be less system admins. You have got to build the case, and you have to reach out to all of, whether it's the combatant commands, whether it's all the service branches, whatever it may be. You've got to get the complaints and also where they'd like to go with the product. And I'll go to the next slide. See, I'm going to go faster now, I promise, because you can take all these slides home and read them, or if you need something for your dog, either way. So the main bullet here that you probably want to focus on, most people forget in the .mil-pif, is leadership and education. Where does your leadership want to go with this product, with this capability? Do they want to take it to an enterprise level? Are they going to host it some other place? Where are they strategically going? And then do the product support it? And get those criteria on the side. So we already talked about personnel, facilities. So are you going to try to migrate this to a data center, or do you want to do all of a sudden go to the cloud with this? So if you've gone to any of the cloud briefings, and if you've seen any of the cloud preparation material, they say, here's your checklist to make sure you're ready to go to the cloud. You put that on for criteria for the product. Put all your little curmudgeons, all the little problems, all the complaints that you think you're going to deal with in the criteria. And then you score them. So it may not be an equal trade-off. All you really care about is one product at a time sometimes, or maybe you're merging them, what the goal is. But you'll see as you read the slide, if you can read the slide, if you can't read the slide, you may be fortunate. But if you can read the slide, you see that there's some conflict of interest in here. So you came up with a score, and I can tell you this is not real data, but there are some real cases in here of conflicts of interest that people would rather have this thing hosted or rather be paying a contractor at a nice TDY location. So it's hard to break that, right? If someone has a conflict of interest and that's their vacation, is to go to their contractor site, wherever we go, there's an ego. There we go. We're getting there. We're getting there. Whew. So also, when we start thinking about, here's what I presented before to a group, and the push for the decision was, do we turn it off or do we keep it? So this was the hot plate I was put on a couple years ago, and it was great. But we have to help the PMs make the decision, and you say, okay, well, I can tell you that everybody looked at their product on the left, and they looked at whether it's going to be turned off or going to be kept. And they ignored the right hand, which was migrate vital features to something else. Because the decision was whether we're going to turn it off long term or whether we're going to keep it long term. But because it was either red or green, they said, oh my gosh, you want to shut my thing off. No. We like it. It's an application, but only one person in the world knows how to use it, so we should probably centralize it, right? So they missed the point. Presentation of the decision, right? So you're talking to a group of people. And at the bullet at the bottom, the bumper sticker, what you're going to come up with after we present this as system engineers is, oh, well, I'm going to really complain now because I didn't have time to really give you my complaints in the first place. But now it looks like you're going to go forward with a decision. So I've got to come up with something. And you get some real winners at that point. And they're actually good. That's when the rubber meets the road. They said, no, I can't do this because I have 5 contracts and I can't separate them. And here's my deliverables for these contracts. A lot of them very good reasons, but they never brought them up. So you'll need a second layer of analysis on some of your key decisions. Not for all of them, right? So it's a negotiation back and forth, but you've got to take care of your program manager. You've got to take care of your PEO so that there was some analysis put into this. And painful as the analysis word is, you know, and you don't want analysis paralysis, I got it, but just be prepared that it's not going to go smooth. So what do I propose to you is adding on a layer from the start with DoD CAR. That's the Cybersecurity Assessment Review that uses NSA's Threat Framework. And this is probably where it gets more interesting for people who are cyber. So it's like the RMF type of framework as far as you could quantify something and come up with a recommendation, except for it is based on threat activities. So we know these are threat activities that our opponents are doing, that the intel world has captured, that the commercial world has captured. So when I talk about threat activities, the takeaway for the vendors is this is a requirement and a capability you need to say that you're meeting. Don't come another with an IDS, IPS, or replacement. Once again, tell me how you are solving threat activities. And we can see if you're trying to game it and say, okay, just like a PM tries to game it, oh, my product does this, but it could do these, or it enables these. That's not what we want. We want to, what do you do well? There's a pocket for everybody's stuff or every type of capability in the threat framework. So anyway, so we will, the PM can use a threat capability coverage scoring, it's tough to say, based on how much of the threat map the heat map and the threat map you cover, but sometimes they may just be concerned about 2 or 3 boxes. So what is the government's concern, and what can your product do? Just talk to that, and then the otherwise, all the .mil-pif has to do with sustainment, training, all the ONS support for it. So we're going to go over a rough software engineering model of what it looks like, what a threat activity looks like, and why it's going more and more logical as opposed to perimeter and hard-based currently as we go into the cloud. And then we're going to talk about how the drawings that we're going to supplement our current activities with NSA to supplement the threat framework descriptions with system engineering drawings that tie over to the RMF will be your next way forward. And you'd want to start, if you're going to do a new system, you'd want to start with how strong does your system need to be based on the threat, right? So if is it in a DMZ, is it going overseas, or is it protected behind a cross-domain solution? So what is the threat to where you're deploying it and the capabilities you have? And I know you can't read this, and that's why I put it up there. No. So there's some stages as far as getting a capability score, but you may not need a capability score. You may just need to know what the impact is. Capability scoring has to do with, if you look on the left, there's a threat framework. The expanded diagram of those boxes is about 150 plus threat activities that NSA and the commercial world with MITRE ATT&CK framework has captured. If you have a product, whether you're government or vendor, you want to say, which one of those threat activities do I protect? What are the capabilities that protect those activities? And what level of protect, detect, respond, identify am I at? Am I good at all these? Am I good at some of them? So you need to look at this. And when the government replaces a product and we're swapping something out, some of these capabilities, back to the original or one of the earlier slides, some of the cyber capabilities may already be embedded into an enterprise service because they can do some, let's just say they do some identity checking, there may be some inherent break and inspect, or there may be some TLS 1.3 type stuff. So there's going to be properties that are going forward, and as the commercial world leads forward with it, we need to take it. We need to take it if it's a proven solution. So you go from the threat framework. The heat map is a really cool thing because NSA has the intel on exactly what the most, and these are notional data, unclassified. So, but they know what the worst problems are. and you can get the heat map on an unclassified form. Sound like you can, it's like I'm selling it down to 7-Eleven. But you can get the heat map in an unclassified form for $19.95. And it will tell you what the hotspots are. Now, what it doesn't do when you have to talk to NSA and get onto TS side is nation state stuff. Am I deploying to some place that I really need to be more concerned about the certain penetrations because of their infrastructure? Capability mitigation scoring. So you take all of those 150 boxes and then you extend, put a column for every one of those boxes all the way across. 150. And then for every one of those columns, you've got 3 subcolumns for protect, detect, respond. That's what a DoD CAR assessment is. It's a lot of work, and you need your SMEs there, you need some contractors and vendors there to say how much do we really cover? Do TTPs cover this, or does an application cover this? Does the infrastructure cover this? So, okay, and then as a result of that, you get a graded scoring, and you get a kind of a rough chiclet chart there of where your hotspots are. But you can twist that. I mean, twist is the wrong word. You can manipulate that based on, well, I know my heavy hitter is on the heat map, the top 3 over there on the left, but all I care about is the 2 on the right. And then you say, okay, this is my assessment, this is my zone, this is my environment, and from my environment, these are my scores, and here's our recommendations based on the couple different capabilities. Right now, we look at capabilities, not products, but you can look at products. Vendors could look at their own products and hopefully be unbiased on the score, because wherever we go, there's on ego. There we go. Good. So we have to neutralize everything, right? To everybody's benefit. We're all on the same team here. The adversary is not government, the adversary is not the vendor, the adversary already has both of us out, and you're fighting the same battle we are, right? So how does this tie over to the acquisition world? How many acquisition people do we have that were trained here? All right, we got a couple. Good, good. So DoD CAR ties over to acquisition inside the life cycle for documents you would put together for your acquisition decisions, whether it's your AOA, your ICD, whether getting ready for PDR. Specifically, right now, it really applies to, most people could see, it applies to what you want to test on. Because then you can say that I replace a capability, and how should I test it based on the description of the threat activity. So the threat activities are not just capabilities/requirements, they're how you want to test and how we want to make sure when we migrate from one application or one vendor to another, how can we make sure that we are cyber secure as much as we can be for our environment. So this is a very light model. You don't have to read it. It's a take-home assignment that you don't have to return. Please don't return it to me. So there's threat models that we have. Essentially the threat model, the picture that I showed you before with the diagram is a hierarchical OV5A. Go down deeper into the activities, it's an OV5B, and there's more description. And at the bottom, the scoring model is a capability mapping, a CV6. Normally you do a capability mapping for engineers, you remember CVs, capability mappings for here's your requirement, here's how I'm filling my capability. With DoD CAR, you're doing a capability mapping, but the activity is not the good activity, the activity is the bad activity. We normally do the con ops and what the warfighter wants to do, then we say here's the capability that matches over to it. So here we're doing the mapping to what our adversary does and how you can defeat it with capability mapping. And then your architecture models, the input to whatever you're putting in, it could be for your OMB IT300 or whatever you're doing for your maze, it feeds into your architecture models. And you want to get it documented inside your acquisition documents, whether it's the acquisition strategy, your SEP, your high-level diagrams that go up, because in a couple years when you need to change your cyber strategy, you're going to have to change those diagrams, and you want justification, kind of getting to the end point. Oh, we're doing okay. We've got about 20 minutes. I'm checking for sleep. No, not many. Good, very good. So from a software engineering perspective, it's easier to describe what happens in every threat across the board. So everybody is familiar with class models or object models. So let's read across it, or I'll read across the top the blue, which is, so a class actor, and it reads like a sentence, attempts one or more threat activities against one or more system service, producing 0 or more impacts. I said, well, that's pretty obvious. Well, yeah, it is a high level because you have to do an abstract model in software. But what's not obvious now is the bottom piece, the cybersecurity capability. Back to our other foot stomping, is those cybersecurity capabilities may be owned or allocated inside your system service now. That's the way we'd love to go in DoD. If you have a capability and you know that it has a certain language or it's on a certain type of platform and you know what the weaknesses are, we would like you to say what it takes to protect it. I really don't want to have to solve all the problems with something we don't know yet and then deploy it and then have to pull it out in another system that puts a protective layer on it and then containerize it, and then there's another layer of security on top of the containers, then I've got to deploy the containers. You know, we could all say that would be great, but for legacy stuff we already have to do that, but let's not go forward that way. So essentially it reads just like that, a sentence. And every one of your attacks are to that degree. They may not get an impact, you may not have a capability in some cases. But as we go to the cloud, the attacks are going to be logical. We don't have contiguous storage in the cloud. Not going to have contiguous execution in the cloud. So we have to think about what's being done, what's the activity, what's the service, and what's the threats to the service. If you break it out, do you have problems if you have a paging issue, right? The classical computer science paging problem, right? And then you have to reestablish. If you don't think there's a problem, think about active-active for all your services, and then putting cyber on top. That's the problem. It's painful. And then the languages, et cetera. So you've got to help us solve this. Help us solve this up front as part of your product, we would prefer. So this is our recent kickoff and activity. We're working with NSA, Johns Hopkins, APL, and MITRE. In the upper yellow box is a threat framework description. And as most of you who are engineers look at something, you say, I hate written requirements, despise them. If I could like them anymore, I would hate them. I mean, I don't like written requirements because the English language, wait a minute, has holes in it. How about that? Imagine that. So you read this, and then you have to break it into phrases, and you have to get the prepositions, and then you have to add, and you say, well, okay, so start diagramming it. Our approach right now is we want to diagram the activities, which are the colored circles and the orange gain. Those are the verbs inside of the sentence, right? Typical classical modeling technique. Verbs look like this. Nouns look like this. Things that happen look like something else, right? So the circular boxes or oval boxes are the activities that the adversary takes. Upper blue boxes, kind of like what we had before, those would be your system components. So when you look at saying, here's my architecture, here's how stable my architecture is, you would apply a name to this. What kind of job schedule do I have? Oh, I didn't even think about that. Or what kind of permissions? Well, you need to think about that. That's going to be part of the assessment. The earlier you can do this with your smart people before you bring in a Tiger team to look at DoD CAR and do the assessment, earlier you can make this part of your diagramming and your system description, the better. Down at the bottom, there are swim lanes. Protect, detect, respond, and identify. So what NSA is doing right now, and also, I forgot to mention NIST, but NIST right now has taken the RMF controls and said, where do these controls tie over to the threat activities? So NSA at the same time is taking these threat activities and saying, what kind of capabilities are associated? So we're decomposing the threat activities to propose sets of capabilities that you would want on your baseline, and then you would say how well it does the threat activity. And then the NIST is taking the RMF. So we want to come up with a modeling approach that says, okay, here's my security capability. For example, system log files. I'm looking at those. And it combats the execute the program or tracks what the periodicity of controls are, and it maps to the RMF controls. Does anybody I'll say it louder, does anybody want to have a quicker RMF assessment done? Well, everybody's hand should be up on that one, right? So that's what we're trying to do. Inside the RMF, there's a threat section, and we're saying that the best definition of the threat is a threat activity model and the threat framework. So it helps define it. RMF, a lot of good, but what happens to our engineers and our program manager? Oh my gosh, Ernie, I already got to do RMF, and I got to do an ATO. Now I got to do this. I said, no, you don't have to. I mean, you can be vulnerable. You can explain why you never succeeded. It's up to you. So if you're familiar with the cyber survivability endorsement, has anybody heard of that one? Nope. Couple. Yeah, good. So that's that's a DoD mandate for your programs at a PM level, that they have to show this thing is cyber survivable based on the tax and based on. But let me tell you, the one thing you want to look out for when you see the cyber survivability endorsement is most of the program is based on the assessment of the actor, as opposed to your system. So if it looks at the actor, it immediately starts to go into nation-state problems. What does China do? What does Russia do? How am I built for this? And then you say, okay, you can design your system to be strong against a medium-sized adversary or a skilled adversary, and then you say, okay, and then what's going to happen? You deploy your system, and after you deploy it, you have a problem, and somebody says, I thought you did a cyber survivability endorsement review, and you say, well, I only thought that was a medium skill level, and by the time I got my program through Milestone C, they had actually paid for more people, and they were better. So if you think about, and I'm telling you as an engineer, and your PM has to do this, the CSE, look at it this way and present it back to the PM. Do you want to go on record as saying, I'm okay with having a medium level threat solution or risk solution for cyber? If you look at the descriptions and your neck is on the line, you'll say, you know what? I'm worried about high skills in each one of the areas, because that's what you want to plan for. Now, where does that get you? That means you got to spend a whole bunch of money. So that takes you back to what are the activities you think are going to happen. So you can size up your adversary, but if the adversary, if they never attack a perimeter and they always go after email and credentials, you've got some history on what you want to protect against. Okay, so this is a bigger picture of that same sentence and what it would mean. This is why diagrams, and you can come back and you say, Ernie, this isn't 100% correct. And I know, because I got to have the smart people work on these sentences and diagram. But it's not just one specific activity. There's some enabling that has to happen. There's some initiation. If I was going to get into a point where the task scheduling had been changed in a state of persistence inside my OS, somehow they got in there, right? So the threat framework doesn't explain all the connections, how it gets there. Right now we look at specifically one activity, but so we're trying to expand that out and say, what would it take and what do you need to be aware of before earlier in the kill chain? Maybe I forgot to preface that the threat framework itself is based on the kill chain, right? You get in, you stay in, and then you exploit and send out and take over with command and control. And all those activities are based on the penetration into an endpoint, data center, whatever device, and then controlling your network or individual device. So we've kind of killed that one here. I think we're almost. So these are the obvious ones. So everywhere we go, there's an ego. Thank you. So how do we make sure that we are communicating with architecture diagrams, capability diagrams for the PM to neutralize these egos? So a thing about, since we have like about a couple more minutes before we go straight to questions, it's always frustrated me about our government decisions course, everybody could probably start laughing now. On the inside, there's a government employee saying this. But what we do is we make a decision based on the best guidance, best knowledge available, and the time allocated. But it's pretty much like an apple. You go to the grocery store, and this has always upset me about the apple, even more than the government decisions, is I go to the grocery store, and there's a label on there that says fresh. And the label's in plastic. 2 weeks from now, that apple's going to be at home, and it's going to say fresh. And yes, everything's the same. It's not the same. So you could say your cyber decisions are rotten to the core, however you want to do it. I don't care what kind of analogy you want to do with that. The problem is every decision we make has a lifespan. It has a life cycle. If you do any kind of trade-off, if you make any kind of decision, the best thing you can do is say, what's the decision criteria? We kind of covered. What's the extended criteria? What were the factors? It's not just General so-and-so said this, or the PM wanted this. Okay, we'll document the PM wanted it. The tricky part, and this is also from the CMMI world, is in the CAR and DAR process areas. You talk about, after you make a decision, when is the time to revisit that decision? When the OS changes, or we go migrate overseas? So when does the decision need to be revisited? You probably have a lot of those decisions inside your family, right? Well, we won't go there. That's a whole different topic, right? Just get me in trouble. So every decision has a lifespan. Just like I have a lifespan. You know, there's going to be a point that I'm not going to be wanting to drive anymore, and that's going to be, you take the keys away from me, and you're going to have a problem, right? So that means a control, and wherever we go, there's an ego. So how can we help the PM? We can communicate clearly, stage the decision, show them what the factors are. Your responsibility as an engineer, a systems engineer, is to show the dependencies in a roadmap form. Not usually done at the cyber level, usually done at the portfolio level, but now, once again, cyber is becoming so complex that it is a system of systems, and you need to treat it that way. And, okay, so this is the part that most people don't like. If you do integrated baseline reviews or technical reviews and capture what the problems are as you go along, I have a couple people here I see from that work for me, and they're familiar with this. If you say what the problems are with the test documentation, is it ready for production? Is it ready for design in a PDR type of approach? And you document what the problems are, you'll find across the PEO and across multiple programs, you have the same problem, or you'll have a great strength from one group. I've got one group that's doing Agile, and I've got some people doing DevSecOps, and they're doing a safe type format for extended Agile frameworks type of approach. Then you take their approach and you escalate it. But you've got to have measurable data, and it doesn't have to be nitpicking all the way down. When we talk about measurable data, we're not talking about metrics. This is going to be a pet peeve. Metrics being combined measurements, or a value over time, or a value on a baseline. A measurement, it just could be a number. If you get the numbers, you can crunch the raw numbers a different way. But if we give you a metric on a contract, shame on us a lot of times, because you can say, I can manipulate the metric to do something else, and I can always get you the right number, but that doesn't mean you're going to get quality or what you want. Okay, data for integrating the program management, we said that. And then before changing and requirements and controlling change, if you've got it documented and you know what the change being proposed is on a diagram, you can go in and say, this change you're telling me shouldn't happen. Or I need money, or you can take away my money, but this line disappears right here. See this? Cybersecurity for OCONUS, and the data, that just doesn't happen. Okay, so make it clear, make it so that it's not a bunch of verbiage, like this slide, and get justification for funding, or justification not to take the funding. We have all of, 7 minutes? And we have to go 7 minutes. Do I have any questions? Otherwise, you're going to say, yes. Do we have microphones or, yeah?
Jeff Kubik with Jacobs. My question is, this approach gets you to the design and initial ATO, and your quote at the end, every decision has a lifespan. The OODA loop of TTPs for adversaries in cyberspace is going much quicker than this model.
Right.
So how quickly do you anticipate the threat matrix being updated so that people working in security operations centers can actually get feedback to the PMO that certain security controls are compromised?
That's a good question. So the real issue with any kind of framework, it only moves but so fast. And then we put diagrams on it, and then the real world's changing. And that's at TTP level. So I guess we should take a little bit of a side path here to talk about the difference between vulnerabilities and threats. So a threat is something that somebody can do to you. You have a Doberman Pinscher as your neighbor's dog. That could be a threat if you have a kid or you're concerned, et cetera, right? That's a threat. What's a vulnerability? Well, a vulnerability, for the most part for us, you need to start with the core issue of the complexity. A vulnerability is the DNA of your software, the language problems that they didn't know were holes in the language until they deployed it in an operational suite. So most of what we're doing for TTPs, if it's related to vulnerabilities, it's fixing DNA in a product that sooner or later has to migrate and go away. So how do you, that's one type of change. So you could fix the DNA in Ernie, but it would take a lot to make me be able to get a suntan, right? Probably not a good thing. So is it really worth that effort? You have to figure if you're going to protect it, or if you're going to say, okay, it's time to move on, so don't deploy Ernie to Hawaii. Bad idea. So if your threats are moving and the adversary is moving, then the threat framework, they gather the information. This is where we are actually looking to the commercial world. Right? So there's other vendors that look at DNA variances of the documents, or that look at changes in the data transport, the size of the data, or whether it's FOU data that shouldn't be floating all over the place. So there's different approaches that have to be deployed with the tactics. And you're right, so tactics will always change, and tactics wind up being, if you take the threat map and you say, here's my heat areas on the heat map for the threat framework, and I say, okay, I'm really concerned about this, but now I know, based on the latest tactic, they're coming in via these four, and then combining these, and then sitting there for a week, right? Yeah. So the framework, and you're right, you're exactly right, because my push today is to get people to realize that the assessment of a network, the assessment of a framework, and that architecture needs to be the left of the acquisition process. Right now we're deploying tools to find stuff, but it's already in operations support. So we have to engineer so it's safer ahead of time. And you're right, it's not a full solution without the ONS moving fast as they possibly can. Next. Where are we at here? We got a couple minutes. Yes. Everyone else is asleep. I'm sorry.
So good morning. Thanks very much for coming out and speaking to us. I just had a quick question, more tactical question relating to the next iteration of JRSS, and just kind of what do you see as far as the requirements definition kind of being unveiled to industry?
Wow. Well, after this one, my resume will be out on the street. I have no job after this one. So, no, that's a very good question. So JRSS has to evolve. I don't like to use that word. because in this case, right now I'm temporarily or in charge of a Tiger team for the next generation. There is no formal acquisition set of requirements yet for going past 3.0 and the 2.0 type baseline. But the whole world, I can tell you that the whole world of JRSS, as I'm pushing it, and as our Directorate sees it, has to go towards the enterprise services taking up some of the responsibility of JRSS and making the JRSS baseline focused on the integrated out-of-band data, and then all the capabilities that are in JRSS, because it has a lot of good stuff. JRSS, for the most part, probably, I'll say probably, but in my opinion, needs to move to a supplemental approach for security as opposed to the core security solution. Right now we have a Swiss Army knife that's 45 pounds. And all some people need to do is eat a piece of cake. And it's a strong set of tools. But the question is, if I have malware tools, and then I've got IDS, IDP type tools, and perimeter type tools, IAP type tools, and then I have cyber SA tools, aren't these really supplements to, shouldn't they be supplements to the current endpoint solution, the current perimeter solution, the current cyber SA solution? Should it be more of a supplemental, and then based on the enterprise services growing, and they grow at a different rate. The endpoint immaturity is growing at a different rate, mobility coming into the endpoint. Perimeter, where is the perimeter? Where's the perimeter when we go to cloud? How can JRSS, so instead of having the 45-pound Swiss Army knife that is good for a lot of things, I said a lot of things, so I'll have a paycheck tomorrow, but it's good for a lot of things, then we could maintain it easier if it were separate configuration items, separate baselines that integrate. Separate baselines that integrate. So instead of the Swiss Army knife, you have a set of silverware. And here's the fork. Then the service branches could say, you know what, I'm worried about my east-west traffic and stuff that goes through my data center. So, you know, I like JRSS, but, you know, what if we do the cloud-based internet isolation? I may not need most of the JRSS web-based reverse proxy type capability. So we're going towards that method. So why don't we make the enterprise solutions solve our bigger cyber issues? I don't have a set of requirements, but that's the vision. Right. Are we at 9:15 now? Everybody's nodding their head, yes, get me out of here. Is that what? 9:12. All right. 9:13. Oh, there you go. That's it. Got 2 more minutes. So let's give a couple stories here. I'm trying to think of something that don't get me into trouble, but that's tough, but we'll do it anyway. Oh, you have one.
Hi, I'm Meg Weinberg. I work for MITRE, and I was interested in the one slide that you had up there where you were talking about APL, NIST, MITRE, working with, not that one, I think it was the one before that one, or maybe...
Right, this one?
The
This
one
one right
where you
here.
were talking about, the thing that captured my attention was the work that NIST is doing to map security controls, I think,
Yes.
to the threats.
Yes.
And I was wanting to understand what the maturity of that work is. Is it available? And I think you mentioned some other things, other work that's being done to align these, like the DODAF, the RMF, and the DoD CAR. I think that was, you went through it rather quickly.
Well,
Do I have it right?
no, you have it right. You have it right. Yes, I did go through it quickly because I want to make sure I got through it. But I want to go on record that there was something I said that captured attention. So that was good. Thank you for staying awake and something you were interested in. Yes, The RMF work that's being done by NIST, and NIST obviously a standards group, they're going to wait till it's fully tested to a certain level. That is being worked with NSA and with NIST in the DoD CAR and also GovCAR. DHS has a GovCAR process equivalent with a framework. So that's not released yet. We saw it in a pilot, but we're going to take what their draft is for the mapping along with the NSA decomposition of the activities from the threat activities to sub-activities to over to RMF. So that's what's going on. The other piece you mentioned, so DODAF. So DODAF diagrams, if you look at the center of this, you have an activity diagram, which is typically what the SV4 type views and a couple SV6s, depends on which the subletter. But it's an activity type diagram. It's a business diagram. So the best way to look at that, to answer your question, is there's a business of threat activity. And this is modeling the business with a DODAF type equivalent artifact that ties over to system components and then down to RMF. Did I lose you? Okay. Okay. And I think we are at 9:15. Are we? 9:16. Perfect. Congratulations, you earned your CPE. I know you're clapping because it's done. I'm okay with that.